This is the first live cat recorded on film, and it's being dropped to solve a physics problem. Why do cats always land on their feet? It's a question that was driving 19th century scientists nuts until one of them used an unexpected tool to solve the mystery: a camera. Etienne Jules Mouret was an obsessive scientist and inventor who analyzed how things moved. And he started experimenting with photography at a time when the medium was mostly used to document static subjects. But his goal was to capture motion. And he did that by building on a basic principle of photography: exposing a photosensitive material to light and then covering it in darkness.
So his way of creating this darkness and light was to have a disc with slots in it.
By controlling the light as the subject moved across the frame, Mouret was able to record movement onto a single glass plate.
Essentially, all he does is block that light intermittently. A slot from the disc opens, and then there's darkness as the man moves, opens, darkness.
This technique is called chronophotography, and the results show something human eyes will never see on their own: individual stages of motion. A couple years later, Kodak introduced celluloid film, and Mouret updated his slot camera in a crucial way. He swapped the single glass plate with a roll of film that moved in between exposures.
So light, an image is made; darkness, the film moves on; light, an image. So it's a movie camera is what it is.
Mouret made a lot of films for research purposes and even tried dropping other animals to see if they'd land on their feet, specifically this rabbit and this chicken. Which brings us back to the cat. It seems to be able to right itself by flipping in the air without pushing off anything first, which would contradict the law of conservation of angular momentum. Sounds scary, but stick with me here. One of Newton's laws of motion says that something in motion can't just stop itself unless an opposing force acts upon it. Basically, you can't just change direction mid-air, Wile E. Coyote style. But to the naked eye, it looks like a cat can. Most people assume the cat was cheating by kicking off the hands of the person dropping it, but Mouret's film showed what's actually happening. The first few frames prove right away that the cat doesn't start its rotation from a kick, but what it does do is arch its back.
And by arching its back, it's divided its body into a front part and a back part. And the two parts can work independently.
You know how a figure skater pulls their arms in to rotate faster? That's what's happening here too. Early in the rotation, the cat pulls its front legs in and leaves the back splayed out so the front half can rotate quickly while the back half stays relatively still. Then halfway through, it does the opposite. Front legs stretched out, back ones tucked in to flip the other half of its body around.
And you notice by the time the cat is landing, all four legs are stretched out as far as they can be, which means slow rotation. So the cat has rotated itself, but not overall. The two halves are working in opposite ways.
It uses the inertia of its own body weight to spin each side. And because the two spins operate separately in opposing directions, they cancel each other out. So Newton's law isn't broken. Mouret published his findings in Nature in 1894, breaking down the falling cat problem for the first time. His work remains an early example of using photography for scientific discovery.
What does photography do for science? It records something and it makes it permanent so you can analyze it later or so you can share it. But what Mouret did was show something that the eye could not possibly see, ever.
You might have seen another famous early example of motion photography. In 1878, Edward Muybridge used 12 cameras connected to tripwires to prove that a horse lifts all 4 feet off the ground at some point in a gallop.